Okay, today we are doing the quadratic formula, and your formula is negative b plus or minus b squared minus 4ac, the whole thing divided by 2a. So when you're solving these equations, and they look like this form, what you need to realize is if you ever have an equation that looks like that and it has an equal sign, like equals 0 or whatever, there are three ways you can solve this. You already know two of them. One of them is factoring, because if I could ask you to factor this. The other way is completing the square, which you did either last night or today in class. And the third way is by completing the square. Is by the quadratic formula. So you can either factor problems like this, you can use completing the square, or you can use what's called the quadratic formula. So with the quadratic formula, you can always use the quadratic formula for any type of problem. It's only when factoring when sometimes you get something that was prime. So when you tried to factor it, you would say that it's prime because you couldn't factor it. Well, now you have two other options, either completing the square or quadratic formula. And those always work. So here, the first thing you want to do is label what A, B, and C are. If you notice, A is next to the x squared, B is next to the x, so this is going to be a 1, and C is going to be negative 1. So I have 3, 1, and negative 1. Once I identify those, I can plug them into my formula. So the opposite of 1 plus or minus 1 squared minus 4 times 3 times negative 1. I'm just plugging them in. And it's divided by 2 times 3. Once you have it plugged in, you want to first simplify this part right here inside the square root. So I have 1 squared, which is 1, and 4 times 3 is 12, and it's going to be negative 12 because it's a negative 4, and negative 12 times negative 1 is a positive 12. So 1 plus 12 is 13. So I have negative 1 plus or minus radical 13. I cannot break up square root of 13, so I'm going to leave it alone. If I could, I would go ahead and do my little factor tree and break it apart. 2 times 3 is 6. So now I have this answer, and you always want to make sure that you can't reduce this number and this number by the 6. And it doesn't, so your final answer is negative 1 plus or minus the square root of 13 divided by 6. Number 2. On this one, you got to set it equal to 0 first. So you are going to subtract 6y and add 3. You're going to find what A, B, and C are. So 5, negative 6, and 3. You're going to plug it into your formula. So it's the opposite of B plus or minus B squared minus 4AC all over 2A. And I just plugged all my numbers in. We're going to look at this first. So I'm going to have negative 6 times negative 6 is 36. Negative 4 times 5 is negative 20. Negative 20 times 3 is negative 60. 36 minus 60 is negative 24. So I'm going to have the opposite of negative 6 plus or minus the square root of negative 24 over 2 times 5. I'm just going to make 10. So now let's look at the radical here. We know that we have to take an I out because it is a negative. So I know I'm going to have an I in my answer. And I have to break up 24. So I have 12 and 2 and 6 times 2 and 3 times 2. So I get 2, I'll put it here, 2 radical 2 times 3 is 6. So I have 2 radical 6i. So when I write that, I have a negative, this becomes a positive. I'm going to have 2, and you should put the I next to it, radical 6. If you wrote it like this, I wouldn't mark it wrong, over 10. So now, I simplified the 6, I broke up 24, I took out my imaginary number, I had 2 radical 6. I now have to look at what I call the little triangle, right? And I have to see if I can reduce 6, 2, and 10. What goes into 6, 2, and 10? Well, 2 does. So I'm going to know that 2 goes into 6 3 times, 2 goes into 2 once, so I'm just going to have an I, and 2 goes into 10 5 times. So this is my answer.